Welcome viewers, in this video we'll see the details about sequential circuit or finite state machine. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic sequential circuit or finite state machine FSM. The diagram shows the block diagram of sequential circuit or finite state machine FSM. Now we'll see the diagram. So this combinational circuit with memory element. Combinational circuit, we know that it is adder, subtractor, decoder, encoder. These are all combinational circuit. If the input is given, it will give the output. It will not store any data. That is a combinational circuit. Based on the combination logic diagram, it will produce the output. The memory element is connected as a feedback, then is called a sequential circuit. Memory elements are connected to the combinational circuit as a feedback path, right? So this is the input, combinational circuit, output, and memory is connected. So due to that, we have two different outputs are available, two different states. The next state, present state, right? So this output is based on the input as well as present state, right? So it is based on two things. Normally in combinational circuit, output is based on the input only. But due to the memory element, one bit data is stored. So what is the previous output and what is the input, based on that we'll get the next state, right? So the next state is depends upon previously available state as well as the input, right? Now we'll see this. The information stored in the memory element are at any given time defines present state of the sequential circuit. So 1 bit data is stored, that is nothing but a present state. The present state and the external input determines the output and the next state of the sequential circuit, right? So the data at present, what is available is called a present state. This present state and input will decide the next state. Thus, we can specify the sequential circuit by a time sequence of external inputs, internal state and output. That is present state and next state. Right? It is a time sequence of external input and internal state. So that will decide the output. The counters and registers are commonly the example of the sequential circuits. Right? These counters and registers are made up of this sequential circuit. The memory element used in the sequential circuit is a flip-flop. It is nothing a flip-flop, which is capable of storing 1 bit binary data, right? So it will be able to store the 1 bit binary data. The example is counters and register. Now we'll compare the comparison between this sequential circuit and combinational circuit. We'll see the comparison. So this is the first column is the combinational circuit, second column is sequential circuit. In combinational circuit, the output variable or at all times depends upon the combination of the input variable. So the based on the input variable, the output is produced. There is nothing else, right? What is the input we are giving? Accordingly, the output is produced. But in sequential circuit, the output variable depends not only on the present input variable, but they also depends upon the past history of these input variables, right? So here output depends upon input. This is here output not only depends upon the input, what is the previous state of this circuit. That also decides the next output, that is called next state. That is depends upon previous state and inputs, right? Then you see the remaining comparisons. Memory unit is not required. Here we are using not any memory in combinational circuit. That's just a combination of logic gates available that will produce the output based on the input. But here we are using memory. Memory unit is required to store the past history of input variable. 1 bit data is stored in the sequential circuit. Combinational circuit are faster in speed because the delay between the input and output due to the propagation, this combination faster because the delay between the input and output is due to propagation delay of the gates. Only propagation delays will be there. Then it is the input is given, immediately it will give the output. But the sequential circuits are slower than the combinational circuit because it should verify the earlier, what is the earlier output, so that it is having slower. Easy to design, harder to design, because we need to check what is the present state, next state, storage element, all are available. Here this parallel adder. This example is serial adder. Serial adder depends upon the previous state, right? So these registers, counters, all are coming under flip-flop. Parallel adder, this subtractor, adder, count, then decoder, encoder, all are coming under combinational circuit. Now we'll see the definition of the flip-flop. So the sequential circuit is mostly is nothing but a flip-flop. Now we'll see what is meant by flip-flop. In electronics, a flip-flop or latch is a circuit has two stable states and can be used to store state information. Two stable state means present state, next state. Flip-flop and latches are used as data storage element. 1 bit data can be stored. A flip-flop stores single bit binary, that is binary digit of data. One of its has two states, represent 1 or otherwise represent 0, right? It will store either 0 or 1 as a storage element. So a flip-flop is having two state, present state and next state. It is capable of storing 1 bit data. So in this video we discuss the sequential circuit. What is meant by sequential circuit? That is combination of combinational circuit with memory is a sequential circuit. Then we'll compare the sequential circuit and combinational circuit. We discuss the definition of flip-flop also. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.